Next, we're going to learn about permutations. So let's look at an example to help us think about how we would approach permutations. So in this example, 5 people run a race. There is a first, second, and third place prize. Find all the possible outcomes of first, second, and third place. So the way we're going to approach this problem is we're going to think in terms of the fundamental counting principle, because the fundamental counting principle allows us to look at multiple events and figure out the number of outcomes for each event, and then we combine those in order to figure out the total number of possible outcomes. So how do we combine them? What operation would we use? Multiplication, right? So we're going to use the fundamental counting principle and ask ourselves, how many events are there? Well, let's see if we can identify the events. Can you identify the events in 5 people running a race and having a first, second, and third place? One event would be getting first place. Another event would be getting second place, and the last event would be getting third place. So in order to determine the number of possible outcomes for each event, let's think about first place. Well, if 5 people run a race, how many people could win first place? 5, right? So 5 people could win first place. Now that somebody has won first place, how many people are left to win second place? 4. Now that somebody has won second place, we have one person that's won first place, one person that's won second place. How many people are left to win third place? 3. We know, according to the fundamental counting principle, that if we multiply the number of outcomes per event for each event, we can get the total number of outcomes. So we're going to multiply 5 times 4 times 3. So what is 20 times 3? 60. So 60, there are 60 outcomes in this case, or 60 ways that 5 people could get first, second, and third place. So a permutation is where you have a group of things that are arranged in a particular order. So when you are trying to figure out all the ways that things can be arranged when order matters, you're going to be using a permutation. And if we look back at our previous example, order mattered because we had a first place, a second place, and a third place. So that's what they mean by order matters. So here's the notation for a permutation. It's lowercase n, and it's a subscript, capital P, lowercase r, and that's a subscript as well. So n is the number of things, and r is the number of spaces available to put them in order. So if we look at the previous example, we had 5 people, that was the number of things, and we have 3 spots to put them in. So we had 5 people, and we had 3 places, first place, second place, and third place. So that's how you read the notation. Let's look at an example and list out all the possible outcomes to help us make sense out of permutations. Chandra, Quinn, and Lou line up at a movie theater. How many ways can they line up? Now here order matters because we have somebody that's first in line, somebody that's second in line, and somebody that's third in line. So let's see all the ways that they can line up. We could have Chandra as first in line, and then Quinn could be second in line, and Lou could be third in line. Or, and I'm going to abbreviate now, Chandra could be first in line, and then we could have Lou, and then we could have Quinn. Next, we could have Quinn first in line, then Chandra, then Lou. Or Quinn first in line, and then Lou, and then Chandra. We could have Lou first in line, then Quinn, then Chandra. Or we could have Lou first in line, and then Chandra, and then Quinn. So how many ways do we have here that these three people could line up? We have 1, 2, 3, 4, 5, 6. So here's the 6 possible outcomes. Well, let's use our permutation notation and see if we actually do get 6. So we would have 3 people lining up, and there's 3 spots for them. So there's the same number of spots as there are people. So we're going to start with 3 and start multiplying down for 3 spots. 3, 2, 1, and that does give us 6. So there are 6 ways 3 people can line up at the movie theater. We just saw an example where there were the same number of places to multiply our numbers as there were numbers. This is called a factorial. And so, for example, we had 3 positions in our last example, and we had 3 people to put them in. And when you end up multiplying down sequentially, you'll go all the way down to the number 1. The notation for this is subscript n p subscript n, which is n factorial. And factorial is actually written with an exclamation point. So we could also write 3p3 as 3 with an exclamation point. It's the same thing. Both of those mean 3 times 2 times 1. When using a calculator, if it's a scientific calculator or a more advanced calculator, then you will have a button for factorials. So you can see I have a screenshot here of the calculator that we use on our computer, and there's a button here that says n with an exclamation point. So that's n factorial. Now you do have to get a view and choose scientific to see this entire calculator view. The calculator that you were required to purchase for this class has a PRB button. And under PRB, there are buttons that you can use for factorials. There'll be an exclamation point, permutations, and combinations. Combinations is the next thing we'll study. So to make sure you understand how to use the notation, we're going to calculate each of these without a calculator. So let's do number 1 together. So number 1, how many things do we have total? We have 7, right? And how many places are we going to put them in? 3. So we have 1, 2, 3 places, which means we're going to start with the number 7 and multiply down, decreasing by 1 each time until we filled up the 3 spots. So basically this means there were 7 outcomes in the first position, 6 outcomes in the second position, and 5 outcomes in the third position. So then when you multiply this, 6 times 5 is 30. I'm going to start there because it'll make my math easier. So 6 times 5 is 30. 3 times 7 is 21. So this is 210. So there's 210 possible outcomes for this particular notation. So now I'd like you to try 2, 3, and 4. Pause the video, try 2, 3, and 4, and then play the video and see if you get them right. So here are the steps and answers for numbers 2, 3, and 4. Next, we're going to work with factorials. And of course, you may notice that 4 is a factorial. So try number 5 and number 6 and pause the video and see how you do. You probably noticed that number 6 and number 4 were the same thing. Next, see if you can figure out how to write number 7 with the proper notation for permutations, and then check back. So hopefully you have 12p2. So now multiply this out. We should have 12 times 11, which is 132. Try number 10 and check back. Here you should have 3p3, which is the same as 3 factorial, which gives you 6. Try the next 2 problems and check back to see how you did. For the first problem, I ended up with 5 factorial, which is 120. So there are 9 numbers If I had 0 through 9, how many digits would there be to choose from? 0 through 9 would give me 10 digits, but I have 1 through 9, so that's 9 digits. So each time I choose a digit, there's one less digit to choose from. So I end up with 9 times 8 times 7 times 6, which is 3024.